Hi! Welcome to the MVVM in WPF Survival Guide from A to Z course, where you'll learn the approach to developing real-world WPF applications based on the MVVM pattern. My name is Elias Fofanov, aka Engineer Spock, and I'll be leading you through the course. I began my career as a postgraduate student participating in Microsoft Imaging Cup contest. I've been working with .NET platform since 2003. I've been professionally architecting and implementing software for nearly 7 years, primarily based on .NET platform. I'm passionate about building rich and powerful applications using modern technologies. I'm a certified specialist in Windows applications and service communication applications by Microsoft. MVVM is the most popular architectural pattern in the WPF and other XAML-based platforms. Learning how to apply the MVVM pattern to a WPF application will give you the ability to develop real-world enterprise-level applications. By the end of this course, you'll get a deep understanding of the MVVM pattern and you'll know how to implement your own MVVM framework. In this course, we will look at the problem of applications maintaining, the problem of connecting views and view models, including the View-First and ViewModel-First approaches, how to support the design time data, how to configure and use an IOC container inside a WPF application. We will use the Castle-Windsor IOC container, how to organize the communication channel between views and view models. We will look at commands, attached and blend behaviors, and how to use a static message bus for communication between different components. How to organize navigation. We will look at a hierarchical UI composition. We will look at how to open dialogues, including modal dialogues. The important topic here is how to navigate to parameterized view models if you want to pass parameters into their constructors. What are models in essence, and how to implement validation on domain objects. In the end, we will take a brief look at MVVM toolkits. We will look at Caliburn Micro more closely. Actually, there will be an additional topic. I'm talking about unit testing. In the appendix, we will take a brief look at how to write a couple of unit tests for view models. I felt that the MVVM course will not be complete without any demos of unit testing. The goal of this course is to give you a solid understanding of the MVVM pattern and show the implementation of this pattern in practice. This course contains a decent amount of code, so be ready for that. This course is primarily aimed at intermediate developers. Experts may also find interesting MVVM tricks provided in this course. If you're a beginner, be sure you're ready to take this course, since it requires from you a solid C# background and acquaintance with WPF. Feel free to look at the course description. I am looking forward to see you inside the course. Enroll and start learning the MVVM in WPF Survival Guide from A to Z. If you had any experience with the maintaining of a big application in a long term, you would have known how much pain developers feel throughout the entire process. The code base always tends to become a mess, a big ball of mud, which sooner or later makes developers frustrated and in the end just buries the project. History knows thousands of software projects which started successfully and eventually died because they came out of control. They became unmaintainable, too much so-called technical debt accumulated over time. That's why maintainability is so important. Not only maintainability determines the healthiness of a software project. Testability is not less important than maintainability. Testability, as the word implies, means the ability of an application to be tested. In this context, I am talking about automatic testing, of course about unit testing in the first place. In my opinion, the maintainability depends on the testability. By stating this, I really mean that the testability is one of the primary goals of designing the application's architecture. If an application cannot be thoroughly tested, then it almost for sure cannot be easily maintained in a long term. The next important notion I want to address in the context of applying MVVM is the separation of concerns. Separation of concerns is a well-known designing principle. Following this principle enables us to break an application into independent components, independent as much as possible. This principle underlies the MVVM pattern. The MVVM pattern applies the single responsibility principle to achieve the separation of concerns. Thus, you can say that MVVM helps you to make your application well structured. To sum up, I'll say that you have to apply some kind of architectural pattern on the UI boundary of an application in case you want your application to stay alive in a long run. There's also the MVPVM pattern can be used with WPF, but this pattern is out of the scope of this course. Great! Let's talk a little bit about why MVVM pattern is so popular in WPF applications. During our survey of the MVVM pattern, we will be building a simple application. Let's have a look at the application. I've prepared a separate solution where this application is already written with a monolithic design. This application is about managing a list of students. In short, the application should display a list of students. It should be able to add new students to that list, remove them, edit the existing ones, and submit changes to the data source. Let's look at the application via the codebase. Here is the student class, which represents the main entity, with which we will be working throughout the course. It exposes ID, first name, last name, age, and email address properties. You also can see XML-related attributes. This class is marked with XML attributes because we will store students in the XML file. So we need to mark this class and its properties with the appropriate attributes in order to be able to serialize objects to XML and deserialize them from XML. Let's look at students-repo.xml. Students by default will be stored in the students-repo.xml file. We already have 7 students here. Let's have a brief look at how data access is implemented. Let's look at iDataProvider.cs. I declared a generic interface named iDataProvider_t, implementers of which should provide the access to a data storage. This interface declares the ability to retrieve entities from the data source by their ID, to change entities, add and remove them, retrieve all the entities and submit all the changes. Submitting the changes means that all the changes will be pushed to the data source. I should say that you'll not find such a trivial approach to the building of a data access layer in the real world. I created such a broad and generic interface just for the sake of simplicity, since we're not going to dig the topic of data access very deep. It's a topic for a separate video course. This is just not feasible to explain all the peculiarities connected with the data access. Okay, let's look at the implementer of this interface. Let's look at students.xml-provider.cs. This provider supports the ability to store students in the XML file by using the xDocument class internally. It receives a path to an XML file in the constructor. For serializing and deserializing students, it uses extension methods for the xElement class, which reside in the XML serializing extensions class. You can download sources and look at the implementation by yourself. Now let's have a look at the user interface. Let's go to main-window.xaml. Right now we're in the main-window.xaml file. It has a simple layout. It displays a list box, 4 buttons to manage that list, and a separate button for exiting from the application. Main window will open an additional window in case of editing a selected student. It will open the Add Edit Student window. Let's look at Add Edit Student window.xaml. This window has 4 text boxes for editing the information about a student. It also has 2 buttons. OK, which accepts the changes, and Cancel, which declines any changes. That's all for the acquaintance with the application. Let's have a closer look at how this application is implemented right now and what are the downsides of the monolithic design. The first approach we're going to look at is auto-wiring, when a view just states that it wants to find and connect to its corresponding view model. In order to make it possible, we have to implement some kind of logic, which will be searching for view models by requests from views. I've added a class named AutoViewModel to the MVVM framework project. We are now looking at this class. This class defines one dependency property named AutoAttachViewModel of a Boolean type. You can also see here a method named AutoAttachViewModel. This method will be called each time the AutoAttachViewModel property changes. So let's have a closer look at the implementation of this method. If we are in design mode, then it just returns. Unfortunately, there is no meaningful way to automatically attach a view model in the design mode using this way of connection view models to views. Then we determine the name of corresponding view model by replacing the word view by the word view model, and then there is something I have done in order to know which assemblies we should scan to find view models. Let's omit the details of where does the list of that assemblies come from for a second. After that, we aggregate all the public types from that assemblies, and after that, we try to find the corresponding ViewModel type. After that, we try to create the instance by using an IOC container and set the data context of a window to that newly created ViewModel. We will look at what are IOCs in a moment. Let's get back to the list of assemblies where we are trying to find the corresponding ViewModel. The thing is that we don't know where we should search for view models. We can hardcode the name of the assembly, but you will need to rewrite this piece of code for each application you develop. So, in order to make this approach more generic, we should bring the concept of application bootstrapping into play. Before diving into bootstrapping and IOC, I want to notice that I tweaked the application a little bit. The first thing is that I added a Castle Windsor package via the NuGet manager. Castle Windsor is an IOC container which we will be using throughout the course. The second thing is that I changed the namespace of the main view. It was in the Students Manager namespace, since we changed the default namespace for this project when the main view was already there. Let's have a look at the main view. In order to use the AutoWire approach, we need to set the attached property. Let's do it and run the application. Let's run the application and check if it works. Great, students are loaded, what means that the view and view model are successfully connected. Okay, let's look at bootstrapping and IOC in the next lecture more closely. I want to introduce you to two concepts, Bootstrapper and IOC. Let's start with the second one. IOC stands for Inversion of Control. This is a common software design principle. The main idea of this principle is to invert the dependencies. There are tons of material on the internet, and since the main goal of this course is not to discuss the IOC principle, I'll just show a good example which I took from the Stack Overflow. Let's consider an example. You have a text editor component and you want to provide spell checking. Your standard code would look something like this. Apparently, now the text editor class directly depends on the spell checker implementation. Applying the IOC principle, we can separate the implementation and its interface, thus introducing an abstraction layer. Here is the new version. Now, the client of the text editor class has a control over injecting the implementation of the iSpell checker. This technique often allows us to stub out the required interface and easily test the text editor. Stubbing and mocking are testing techniques. The technique which we applied here to satisfy the inversion of control principle is called dependency injection, or DI. In particular, here we applied the constructor injection pattern. I also want to mention special tools which help to follow the IOC principle by applying dependency injection. These tools are so-called IOC containers. You can find dozens of open-source IOC frameworks out there. You can find heavy frameworks as well as very small and simple. In short, we use IOC containers to manage dependencies and automatically resolve them. For example, We can register a spell checker implementation as a default implementation for the iSpellChecker interface, and then, in order to create the text editor, we can call the IOC container. For example, IOC container will check all the dependencies of the requested type. If it knows how to resolve them, it will create them one by one, and in the end it will return the constructed object. I'm not going to discuss pros and cons and delve deeper into the topic, since I can dedicate to this topic the whole separate course. I'll just attach several helpful links to this lecture where you can learn more about all these topics. The last notion I want to briefly address is the notion of a bootstrapper. A bootstrapper is a place where we set up all the necessary things for running the application. For example, we can set up here an MVVM framework, configure an IOC container, and so on. In my opinion, this place is very often the same as a so-called application root. You can read more about this notion in the book, a link to which I'll attach to this lecture. Okay, that's it. Let's go further and look at how to implement a bootstrapper with an IOC container. Let's get back to our application and try to fully understand how the auto-wiring approach, which we've seen, works under the hood. The first simple thing we've seen is that we check if we are currently in the designer mode. Here you see the implementation of that property, which returns true if we are in the design mode and otherwise if in the runtime. Okay, let's go to the Bootstrapper base class. The Bootstrapper base class is a level of abstraction which is used for moving the responsibility of initial application setup to the root of the application. And the Bootstrapper base defines the following methods: select assemblies, get instance, and configure for runtime and configure for design time. There's also the start method. Let's look at this method. Firstly, you can see that we have the assembly source class. Let's go there. This class is just a singleton which contains a list of assemblies. Let's get back. So, as you can see, we invoke the select assemblies and add the results to the list of assemblies, which we store in the instance property. Select assemblies should be overridden somewhere. We will look at an example of implementation in a minute. Okay, after filling the list of assemblies, we check the current mode and invoke the corresponding configure method. Configure for design time and configure for runtime methods are responsible for configuring the IOC container for the corresponding mode. In the last line, we use a little IOC abstraction. We will use the getInstance method for creating objects, so in this line we initialize this method by a concrete implementation of a concrete IOC container. You'll see the implementation in a second. Let's go to the IOC class. This class is defined in order to give the users of our little framework the ability to use any IOC containers they like. As I've already said, we use the delegate getInstance to resolve dependencies. Let's look at an example of implementation of the Bootstrapper base. I use the Castle Windsor as the IOC container. Here at my application root, I know which assemblies I want to scan through in order to find view models, so as you see, I just return the assembly which contains our main view model. Next, the configuring methods. In these methods, I initialize the IOC container. I register the iData provider student as a dependency and resolve it by the student's XML provider, which will be created with the hard-coded string parameter pointing to the student's repo.xml file in the case of runtime. We will tweak the design time configuration very soon. After that, we also register all types from the ViewModel's assembly, which names end on the ViewModel suffix. If you want to change dependencies on primitive values on the fly, you can use for that some kind of configuration. More on this topic you'll find on the attached link to this lecture. In the getInstance method, we just use the IOC container to resolve, or what the same, to get the instance of a certain type passed in as a function parameter. In order to launch the Bootstrapper, we have to call the start method from the Bootstrapper base class somewhere. I did it in the startup event handler. You can see it here. All the things we covered here can be difficult to understand from the first try. This is absolutely normal. I encourage you to download the sources and debug the process of starting the application. You'll fully understand the interaction between classes. Okay, let's talk about design time data support in the next lecture. This course's primary goal is definitely not unit testing, though I want you to understand the basic scenario of how we can write unit tests for view models. In this lecture, I'll write 2 unit tests for the main view model. Firstly, I'll add a new project for hosting our unit tests. I'll name it ViewModels Tests. I'll add all necessary references to the newly created unit test project. Now we can start to write unit tests. First of all, I'll rename the default class name to main ViewModel tests. Secondly, I want to prepare the so-called system under test, that is main ViewModel. I'll use the test initialize attribute of MS-test to share the SAT among all tests in the class. Tests runner will start from calling to this initialize method right before executing each unit test. The first argument we need is the data provider. In unit tests, I'll use our design time students provider, since it is just an in-memory implementation which does not depend on any external resources such as a hard drive. The other 2 dependencies I'll just create in place. For initializing the view model, we also should call to the onViewLoaded explicitly in order to force reloading of students. After that, our view model gets to the default initialized state. Okay, the first test I'll write will check that the canEditStudent property returns false by default, since by default there are no any selected students. We should make the canEditStudent public. Since we already have an initialized view model, we can just call the action. So we can just invoke the canEditStudent and assert the result. Let's run this test. And it passes. The second test I want to write will remove an existing student and check if it was actually removed. I'll get the first student from the list, then I'll select the student in the view model, and after that I'll call the remove command. In the end, I just assert that this student is removed. For that, I created a separate method isStudentExists. Let's run the second test. Oops, it failed! Yes, this is because we use the single LinQ extension. Let's fix that. Let's run this test again. And it passes. Let's run both tests. And they're both passes. And that's it for the demo of unit testing.